We will determine the area of these two triangles. First, let's do for the question number 7. So we have this triangle with angle measurements as well as the some part of the side length is given as 42. So as a first step, I'm going to mark the vertices as this top one as A, and this is B, and this is C, and this point where the height intersects the base as D. So we are going to apply the trigonometric ratio. So first let's consider the triangle. This is right triangle ADC. So in right triangle ADC, I'm going to apply the tangent ratio. So I'm going to find the tangent of 55. And this is equal to opposite side, which is AD, over adjacent side, that is CD. So let's plug in AD. We know that AD is height. Let's keep this as h, and let's say this is x, that is BD is x, and AD is basically the height of the triangle. So AD equal to height, that is h, over CD equal to 42. So we get tangent 55 equal to h over 42. So this implies we can solve for h. When we multiply both sides by 42, we get h equals 42 times tangent of 42. Sorry, tangent of 55. So when you plug this into the calculator, we get approximately this is equal to 60.0. So basically the height of the triangle we have just found it is h equal to 60. Now let's apply the trigonometric ratio in the triangle ABD. So I'm going to apply the tangent ratio for the angle 20. So I can write down this as tangent of 20 equaled opposite side, which is BD, over adjacent side is AD. So let me plug in BD is x. I have kept this as x, and AD is basically the height of the triangle. So we get h. So therefore this becomes tangent of 20 equals x over h, which means I can solve for x. So x is basically equal to h times tangent of 20. I can replace the value of h into this, so which gives x equal to, I write down here, 60 times of tangent of 20. When you plug this into the calculator, we get the value as 21.8. So basically we found the values of height as well as the remaining part of the base. So we can say that the base is BD plus CD. Base is equal to BD plus CD. BD is basically the value of x, which is 21.8, plus CD is 42. So when we add these two, we get 63.8. This is the base of the triangle, and we can utilize the height of the triangle here, so that we find the area of the triangle. So therefore, we find the area of triangle equals half base times the height. So this is the standard formula to find the area of the triangle. So I can plug in the base as well as the height, which is 63.8 times of height is 60. I take these values as well as this value. So when we simplify this, we get the value as 1914. So this is the area of the triangle given in question number 7. So it is 1914. We will now determine the area of this triangle given in question number 8. So first I'm going to mark the vertices. Let me put this a little bit down. So I'm going to mark this top vertex as P, and this is Q, R, and this point where the height meets the base as S. So now consider the right triangle PQS. In this I'm going to apply the tangent ratio. So I'm applying the tangent ratio for the angle 28. So therefore I can write down tangent of 28 equal to, the opposite side is h, the height is the opposite side, and I'm going to call this SR as y. So the opposite side is PS over the adjacent side is QS. PS is represented by height, and QS is we have the value as 33. So we can solve for H from this. So therefore H equals 33 times of tangent of 28. We can plug this into the calculator, and when we do that we get 17.5. So this is the value of H. Now let's do for the another right triangle, that is PSR. Here as well I'm going to apply the tangent ratio for the angle 35. So I write tangent of 35 equals opposite side is SR by adjacent side is PS. So therefore this becomes SR is represented by Y and PS is represented by height H. So this is a tangent of 35. We can solve for Y from this. Therefore Y equals H times tangent of 35. We replace the value of Y. We replace the value of H over here. So when we do that, we get Y equals 17.5 times of tangent of 35. So we can plug this into the calculator, and this basically comes out as Y equal to 12.2. So now we have found the value of height as well as the Y. We can calculate the area. So first let's calculate the base, which is the QR, and this is equal to QS plus SR. QS is 33 plus SR is Y, which is 12.2. When we add these two, we get 45.2. This means the base of the triangle is 45.2. So we can find the area as half base times height. This is the formula for finding the area of the triangle. So let me replace the value of base, which is 45.2 times the height is 17.5. So basically we find this value. When we put this into the calculator, we get the value as 395.5. So this is the area of the triangle given in question number 8. That is 39, 395.5. So we have found the area of these two triangles.